Stretches about the x and y axes. Part A, investigation. Set your calculator to degree mode. Okay, so I have set decimals, but you can set your calculator to this mode. I have set decimals to this window, negative 360 to 360 by 90, negative 3 to 3 by 1, and degree mode. And we're going to compare the, so you may follow along on your calculator. So we want to compare the graph of y equals f of x and y equals f of kx. So the question here is going to be, when x is replaced by kx, what happens? So we are going to graph y equals sine x and y equals the sine of 2x. So here's y equals sine x, right? We saw this last year. And now we're going to graph y equals the sine bracket 2x. So, and here's nice color, right? And if you have the color calculator, it's kind of nice because you get one line in red, the other line in blue. If you have the grayscale, it's sort of like, which one's which? Okay. So we know that sine x is the red and sine 2x is the green. And so the question, for y equals sine x, when x is replaced with 2x, the graph of y equals sine 2x, the green graph, is the graph of y equals sine x horizontally stretched about the y-axis, so here's the y-axis, by a factor of how much? Okay, so here's the red graph, right? It took from, well, let's just go from here to here. This upper peak went 0 to 180. Now it goes from 0 to, you're saying 360, because you're saying it's stretched by a factor of 2, but what's it really stretched by? 1/2. So horizontally stretched about the y-axis, right, or the line x equals 0, by a factor of 1/2. It's like translations, right? Everything goes opposite again. But it's negative, it should be like that. But it's a 2. But so think about it. So you remember that sine of 90 degrees is equal to 1. So the point 90, 1 lies on the graph. Okay, here's 90, 1. Where is that point moved to? 45. Its image point on the graph. And what you got to just think is this. How do I get a 90 out of 2x? What do I put in for x? 45. So the point is 45, 1. Verify your answer by using your calculator, which we don't have to do because we've looked at the graph. We can see clearly it's at 45. So the image point of xy is what? X over 2, or 1/2 x, y. All right, it's good. It's opposite. Okay. Actually, inverse. On the same screen, sketch the graph y equals sine x and y equals sine of 1/2 x. So I'm going to go and replace this 2 with a, I'll just throw in a 0.5. And so now, let's see, the original graph took 180 to do the top half of the cycle, and now how much does it take? 360. So when x is replaced with 1/2 x, the graph sine of 1/2 x is the graph of y equals sine x horizontally stretched about the y-axis by a factor of 2. The point 90, 1 lies on the graph of y equals sine x. Okay, 90 and 1, and where has that moved to? 180 and 1. Right? And again, just ask yourself, if I'm going to throw 90 into the sine function, I know it's going to give me back a 1. If I'm going to throw a number into here and want to get a 90, the number I have to throw in here is a 180. Right? Then it'll take a half of it and then input it to the sine, and I'll get that. So its image point is 180, 1. Transformation is going to be described by the mapping, so xy becomes, okay, so x, 2x. Predict how the graph of y equals sine x changes when x is replaced with 3x.
Stretch by
Stretch by a factor of 1/3. Okay, so it'll be a horizontal stretch about the y-axis. Okay, so we want to add that, right? So we want to be very So we're going to predict it is a horizontal stretch about the y-axis by a factor of 1/3. Okay, and then it said try it on your calculator, so I can throw a 3 in here. 3. And what we can look at here is we can say, how long is one cycle, right? Well, one cycle is 360 degrees, and now I've got 1, 2, 3 cycles, which means that it's 1/3 of what it was. Everything is 1/3 of what it was. Okay, so I'm getting 3 cycles in that 360 degrees. Predict how the changes when x is replaced with 1/3 x. 3 times. Okay, so again, let's be used to writing out the full thing. So it's a horizontal stretch where about the y-axis, so by a factor of 3. All right, I'm not necessarily going to change the window. I'm just going to change this to 1/3. Let's see what happens. And basically we can say, well, if it's stretched by a factor of 3, then the 90 should be at like 270, right? So, and it is. Okay, why is that? Because if I throw 270 in, then I'll take 1/3 of it and get the 90, and then I'll get out the number 1. Okay, and it says just for this, you may wish to. I didn't wish to because it's just for that question. Set the window back. Don't have to. Didn't change it. Comparing the graphs of y equals f of x and ky is equal to f of x. Sketch graph y equals sine x and 2y equals sine x. Now, if you're graphing, what do you have to graph? You have to graph y equals 1/2 sine x, right? Because on your calculator, it's always got to be y equals. I am not constrained by such things, and so I got to get rid of the 1/3 though. Let's get rid of 1/3, and I can put a 2 in here. So there's 2y equals sine x. Okay, so we're comparing. So the red is sine x. We're comparing that with the green, and what is it asking? For y equals sine x, when y is replaced with 2y, see there's y. Now it's replaced with 2y. 2y equals sine x is the graph of y equals sine x. So what's stretching here? What's happening? Vertical stretch by a factor of. So how does the height of the green compare to the height of the red? Half about the x-axis. Blah, blah, blah. Y sine 2y versus y sine x. Vertically stretched about the x-axis by a factor of 1/2. Okay, again, like you say, if I want to get a y value of 1, then I'm going to have to throw a half in here, which will double it. That will give me the 1. Okay, so the point 91 lies on the graph y equals sine x. Its image point on the graph 2y equals sine x is, so what's the image point? 90, and now we're at 1/2, right? Okay, again, here, let's just pop back here. So at 90, we're 1/2. What's the scale there? 1, 2, 3, it's like quarters, right? So a quarter, half. So 90, 1/2. The image point of xy is x and 1/2 y. So we just take a half of the y value. Okay, good. Anyone want to admit to not being good? Sketch graph y equals sine x and 1/2 y equals sine x. Now, if you want to graph this on your calculator, you cannot put a half y. You are going to have to put y equals 2 sine x. And you can sort of figure out, right? Like when we do the y step, we move it to the other side, what happens? It really kind of does what we think it should be doing, right? But I can put a half y. Let's get thrown a 0.5. Okay, so what happened? Doubled, okay. So formal language, we're going to say it is vertically stretched by a factor of about the x-axis, right? Or perhaps vertically stretched about the x-axis by a factor of 2. So is the graph y equals sine x vertically stretched about the x-axis, which is also the line y equals 0, by a factor of 2. So if the image point 91 lies on the graph, the image point on 1/2 y equals sine x is 90, 2. And the point xy will become x2y. Predict how the graph changes when y is replaced with 3y. Vertically stretched above the x-axis by a factor of 1/3. Vertically stretched. Stretched about the x-axis by a factor of. Verify. So what were we doing? 3y. 3y. Get rid of the 0.5. 3. And do we get that? Yeah, probably. How high should this point be?
0.3.
Okay, let's check it out. Come on, give me the point. Give me the point. 90, 0.333. Cool, huh? Beats the heck out of the graphing calculator. But that's what you can use on the exam, so that's what you have to know how to use, right? Predict how the graph when y is replaced by 1/3 y. What's going to happen? So it's going to be a vertical stretch. What about it? About the x-axis by factor of 3. Let's try it. So what was I going to do? Put a 3rd in there. And there it is, right? It's going up to 3, which is off the screen, but it's there. Right? You know, shift it down. See, look, 90, 3. Generalization. So in general, right? General. If y equals f of x, and x is replaced with kx, so that's our language for this whole transformations unit. If x is replaced with x plus 2, this results in horizontal transformation left 2 units. Right? If y is replaced with y minus 4, this results in a vertical translation up 4 units, or 4 units up. If x is replaced with 2x, this results in a horizontal stretch above the y-axis by a factor of 1/2, if, etc. Okay, so now Durham. So if x is replaced with kx, then the graph of y equals f of x is the graph of y equals f of x horizontally stretched about the y-axis by a factor of. Okay, and we're going to add one more thing to that, because we know that if x were replaced with negative x, that there would be reflection, right? So what we're going to do is we're just going to say it's by a factor of the absolute value of 1 over k. In other words, the stretch depends only on the magnitude of the number in front of the x. If it's negative, then after we stretch, we'll do a reflection. Okay? It's a separate transformation. So we will say it's stretched horizontal. So if you see -2, you just say it's a horizontal stretch by a half. Then I'm going to reflect it in the y-axis, right? Then I'm going to do whatever translations, right? Like, it's sort of the last stuff, right? Stretches, reflections, translations. The image point of xy is It's not x. What is it? 1 over kx, comma y. Where am I here? Yeah. And in this case, if the k were negative, then that would be a negative, but that would do both things, right? It would do the stretch and the reflection. Okay, so we could just say it's 1 over k. I don't say it's the absolute value of 1 over k. It really is just 1 over k, but that would do both things then. And the invariant point. So where are the invariant points? Well, it's stretched about the y-axis, so the y-intercept. Okay, so the y-intercept. Okay, and if it's a function, it can only have one y-intercept, right? I mean, if it had two, then it's not a function. You can't have two, fail the vertical line test, all that good stuff. If y equals fx and y is replaced with ky, then the graph of ky equals f of x, also expressed as, so more likely we're going to write it how? Y equals 1 over k f of x. Right? And the way I like to always just think of it is, when the y is by itself, the stuff on the right-hand side is really doing what it says it's going to do. You know, if there's a plus 5 on the end, it says go up 5. If there's 1 over k in front, it says, oh, we're going to take 1 over k. So here's the graph y equals fx. Vertically, is it vertically? No. Yes, vertically stretched. Yeah, vertically stretched about the x-axis, which remember is also the line y equals 0, right? So just be aware we could give you a line of stretch. Okay, and we don't necessarily have to stretch about the axes like we are for now. Okay, so don't worry. But we could stretch about another line. Okay. Anyways, by a factor of 1 over k, but it's the absolute value of 1 over k, because again, if k is negative, then we've got a stretch followed by a reflection. Okay. The image point of xy is x and 1 over ky. And the invariant points are the x-intercepts, right, of which there can be many. All right, any questions on stretches so far? So now we're going to do some examples, right? And what we really want to get at here is just, here's all the different possible ways that we can talk about these things in terms of image points, in terms of mapping, in terms of describing it in words, in terms of taking a point and changing it to this other point. Okay? So, here we go. The function y equals f of x is transformed. Given the transform functions below, so like 1 is sort of a general instruction, and then there's part A, part B, part C, part D. Okay? Y over 2 is equal, given the functions below, complete the following statements. Okay, so we've got y over 2 is equal to f of x. To produce the equation shown, the graph of the function y equals f of x is stretched vertically about the line. So this time it's about the line. What line? Okay, so it's me. I'm thinking x-axis, and then I'm translating that into y equals 0. By a factor of 2. Okay, but what's that going to become, right? We're probably going to write this as y equals 2 f of x, right? Which says what? Do the f of x and then double it. That'll give you your y. Okay, so that's the vertical stretch by a factor of 2, like when the 2 is on the other side. We don't get to do that with x's, right? When it's x over 2, you can't exactly move that half somewhere. The image point of xy is 2y. For f of 3 halves x. Do you want to try this on your own? No, there's fractions. Graph y is stretched. Okay, so what we might want to do is let's put this back into form, right? So maybe I'm going to write 1/4 y is equal to f of 3 halves x. Okay, and maybe not, right? But you might maybe start out that way. You start on 1/4 y, then you rewrote it with the 4 there. Okay, so produce the equation. It's stretched. Pick a direction.
Vertically.
Vertically. Do we have to do vertically first?
Doesn't.
Doesn't matter. So it does not matter because they're operating under, you think of the image point, what's going to happen? Well, x becomes 2x and y becomes a half y. Okay, well, if I did that in one step, it's no big deal, right? It's like if I'm going to stretch and then translate, that's a bigger deal. Okay, stretch. So Sam chose vertically. About the line, y equals 0 by a factor of 4. So I kind of like, I look at that and say, oh, factor of 4. I gotta look at that and say, oh, thank God it's over there, because that's what it says. It just makes it 4 times bigger, right? You think order of operations, I mean, in a sense, you think order of operations, you'd really go horizontal first, right? Because you would take the x, multiply it by 3 halves, take that number, stick it into the function, get some y value out, and then quadruple it. Okay, but it doesn't matter which order it goes in. It is also stretched horizontally about the line, okay, which is the y-axis, by a factor of, drum roll, this is it, you get this right. Just write it down in pencil. We never use pen in math because you're not that good. Well, maybe you are. No, he's using pen. Don't use a pen, okay? Use a pencil. Get a good mechanical pen. You don't have to spend like 30 bucks. Splurged on a pen. I don't lose them though. So tomorrow I'll walk in and it's my $30 pencil. But it's nice. It's got good weight. Good one. It's got a red ring around the top. It's German, but it's made in Japan. I think it was designed in Germany and made in Japan. It was actually shipped over. The instructions were in Japanese. That's how good it is. But anyway. But I got to ransom note tomorrow. By a factor of, okay, what is it? 2/3. Good. If you got 2/3, it's all good. So really, just think of it. It's the reciprocal of whatever's there. So when it's 2, it's just a half. When it's a half, it's just 2. But when it's something else, like 3 halves, it's 2/3. Okay. The point x, y on the graph, y equals f of x, is transformed to x. No, it's not x. What is it? 2/3 x and y.
4y.
4y. Good. You're on the ball. It's really good. I wish I'd have done that on purpose then, just to elicit that response. Okay, so 2/3 x, 4y. Why? If you throw 2/3 x into here, the 3 halves times 2/3 is going to take you back to just plain old x. Okay. This is the next part, right?
Yeah.
Okay. Describe the transformations on the first function, which is the top one, so that the second function is produced. Okay, we got y equals x cubed, and we've got y is equal to... These are actual functions. You could actually graph them, right? As opposed to the general, like, f of x thing. And it's like, we don't have a ton of room here, right? So we can abbreviate. All right, so what's going on? What have we got? It's a stretch. What kind of a stretch is it? Horizontal stretch about the... Okay, so HS about y-axis by a factor of 1/4. Okay, so you try the next one. Write out what you think it is. Don't be fooled. Like +3. If you're going to get fooled, this is a good time to get fooled, right? Quiz, lousy time to get fooled. Right? It's like, wow, that cost me marks, whereas this is, oh, I got that wrong, but now I see why. I shall fix that. So what am I thinking? HS or BS? HS. Okay, so just ask yourself, what was x replaced with? So there's an x in the original, but now it says what? 1/2 x. Horizontal stretch plus the y-axis by a factor of 2. Horizontal stretch about the y-axis by a factor of 2. Okay. X1 is trivially simple, right? So just write it out as well. It's not trivial. It's okay if you get it wrong. Now's a good time to get stuff wrong. Right? You just got to figure out, oh, right, this is what I have to do.
It's moving over.
Okay, what kind of stretch? Vertical stretch about x-axis by a factor of. See, so you said 3/4. Life is good, right? By a factor of 3/4. Last one. Give this a shot. You might want to write it in the form something times y is equal to, you know, like kind of reverse it backwards, and then, or you can just look at it and say, oh, yeah, that's just this, and so it's that. Yeah, it's good. I like the discussion. Discussion is good.
It's all multiplied together. It's multiplied the whole thing. It's
Oh God, Sam became a math student over the summer. This is like,
You mean last sentence?
whatever. I wanted to give you some credit for starting early, but it's like, what happened to last year's day? So I didn't care, man. It's like, as long as I got through this stuff. Okay, what is it?
It had to be 1/3 on the left.
Yes.
Yes, we're arguing the same thing. It's 3.
Yeah. We all agree, but we're going to argue about it. It's a vertical stretch about the, by a factor of 3. Like you can think of this is y equals a, and this is y equals 3 times a, right? Like how do you get the 3 over top? Well, you multiplied this by 3, which means that this started as like 1/3 y is equal to 1 over x plus 2, and then became that. And the 1/3 y is replaced by 1/3 y, which results in a vertical stretch by the x by a factor of 3, right? 1 over k, 1 over 1/3, 3.
I understand that when there's a fraction versus reciprocal.
Yeah.
Why is that? Right, so it's 4/3 y. Why is it a stretch by 3?
That's reciprocal. So it's by a stretch of 1 over 4/3. Okay. So like, okay, this stretch, right? So we said the stretch is, you know, ky, that leads to a stretch by a factor of 1 over k. Okay, so you've got 1 over 4/3, which is 1 over, well, which is 1, so you divide by a fraction, you multiply by the reciprocal, so it's 1 times 3/4. Okay. Now the easy way is just flip it, right? But it is the reciprocal, 1 over 4/3, which is 3/4.
So the reason is because it's over a 1.
Well, the reason is the stretch is 1 over that number. And when that number is a fraction, you have to multiply by the reciprocal. When you divide by a fraction, divide by 4/3, you multiply by 3/4.
When it's a whole, you just.
When it's a whole, you're just going 1 over. The point x, y lies on the graph y equals fx, stretch transformation, and write the equation of the transform point if the point x, y is mapped onto the image point. So now you're getting the image point. Remember, the image point, it does exactly what you think it does, right? Like 2x says you are going to do a horizontal stretch by a factor of 2. Okay? So what I would do with this is, when I'm looking at the image point, I would describe what's going on, right? So I look at this, say xy became 2xy. This is a horizontal stretch by a factor of 2 about the y-axis. So hs by a factor of 2 about the y-axis. I think that's the first time I reversed them, right? So when you talk about horizontal stretch, you got to talk about where is it stretched, which is about the y-axis, and by a factor of what. But it doesn't matter if you say about the y-axis by a factor of 2, or horizontal stretch by a factor of 2 above the y-axis. I would just like to see both of those pieces of information. right? It's like HT left 3, HT 3 left, that's fine. It's a horizontal translation, I'm going left 3, I'm going 3 left. So whatever works for you works for me, right? I can figure it out. I can always take left 3 and say you wrote 3 left. I think those are the same. Okay, so so we're supposed to write y equals f of x, we're supposed to do the transformation form, so what would that be? Okay, so I'm going to do a horizontal stretch by a factor. So let's think about it. Horizontal stretch by a factor of 2 says that what is replaced with what? X is replaced by 1/2 x. So we're just going to write f of 1/2 x. Okay, makes sense? So basically, look at the mapping, describe it in words. I cannot overemphasize, although I will, that you must always describe everything in words. If that's how it works for me, therefore it must work the same for you, right? Because we are all human beings and must think exactly the same. Okay, but make sense of this yourself, right? It doesn't even matter if it's gibberish to somebody else. Like, if you can make sense of this, that's what counts, right? So you may want to go home and summarize the notes for yourself. Write it out. It's like a Betty Crocker cake mix, right? It's like just here are the steps that I follow, right? And this is individual. If I follow these steps, I will always get the wrong answer. If I get wow, success in math. I will always get the right answer, right? Then if you follow the steps and something goes wrong, you're missing a step, or there's something missing that you're not, right? So you follow your steps and hopefully get the right answer. Not Nigel, right? Because he was wrong. But, okay, x 1/4 y. What's going on? Vertical stretch by a factor, vertical stretch about the x-axis by a factor of, that's by a factor of 1/4, right? Image points, mappings say exactly what they mean. Take the y, give me a quarter y. Okay, that's a vertical stretch by a factor of 1/4, right? If this number was 16, it's now 4. Okay. So, what do we're going to do this in 2 steps. So first we're going to write what? And then we're going to write, I really like this because it just says what it's going to say, right? So that's a quarter. Okay. But let's get used to seeing the 4y, okay? Why 4? Because on January 25th, when you see 4y, you're going to be, oh, right, yeah, it's like so September. Okay? Whereas other kids in the province are going to be, I've never seen it there, right? Like they never put that in front of y. They just always wrote y equals 1/4 because that's mostly how we see it. Uh-oh, 2 things. So let's go left to right. So what's the first stretch? HS about y-axis by a factor of 1/3, and a VS about x-axis by a factor of Okay, so again, we're going to do 2 things, right? So we'll write the ky is equal to f of lx. Okay, so what's the ky? 1/5 y is equal to f of 3x. So y is equal to 5f of 3x. Now, when it's all on the right-hand side, the 5 does exactly what it says, right? It's vertically stretched by a factor of 5, but then the 3, right? Anything with the x is always opposite, right? If it's x minus 2, like y minus 2, I can move that over, it becomes a plus 2. I cannot do anything other than make sure that the x is by itself in parentheses if there's a translation, right? So if you're seeing like 3x minus 6, which way is that translated and how much? So it's right, how far? 3x minus 6. As you see, bracket 3x minus 6, it's right. That's why, yeah, it's right. 2 units, because it's 3 bracket x minus 6, right? X minus 2, sorry. Okay? It's okay, you're going to get it wrong at first, you'll get it right later on. But maybe that's something you want to make a note of, right? When I see 3x minus 6, I must then write 3 bracket x minus 2. Then I can read the transformations, right? How many more left? So like 4 or 5. Okay. The function y, well, we might as well just finish it then. Then you just have homework. No. The function y equals g of x is horizontally stretched by a factor of 2 about the y-axis. Write the equation of the transformed image in terms of y equals g of x. Okay, so how do I do a horizontal stretch about the y-axis? By a factor of 2. X is replaced with, let's go with, how do you horizontally stretch by a factor of 2? 1/2 x. It's like, you left way too much space if that's all there is. Okay, if that's all there is, and yeah, there's way too much space. But that's it, right? So on the diploma, some of the questions really are that easy. Like, yeah, a lot of them are, but there are some very straightforward ones. You'll be very suspicious of them because it's like, it can't be that easy. Okay, some of them are, so just, you know, be prepared to, okay, maybe it is, but I will come back and check this question because there must be a trick in here, and I just don't see it. The function p of x is equal to the square root of x minus, so this is an actual function, right? We could do stuff with it, we could graph it. Is vertically stretched by a factor of 1/3 about the x-axis. Write the equation of the transformed image both in terms of x and in terms of p of x. So my preference would be to start with the p of x, which is not the person who wrote the key decided to go otherwise. But okay, so let's do the x one first. Okay, we're going to do vertical stretch. So here's what we start out with, right? You got this p of x. You got to go to the p of x, right? So you're going to write y is equal to the root of x minus 6, right? Just write it as y equals. Okay, so say, no p of x, just y equals. Okay, now let's do the vertical stretch by a factor of 1/3. Y is replaced with 3y. And then we're going to write y equals, and what are we going to get? 1/3 root x. Again? Yes. Okay, so the 1/3 multiplies this term giving you y, this term giving you 1/3 root x, and this term giving you 2. Okay. So think about it, because this thing moved, whatever this did, it moved down 6. Now I'm stretching it by a factor of 1/3, so it's not moving down 6 anymore. It's only moving down 2, right? Like it's a third as big as it was, but it's not moving down the same amount that it did. It's moving down 2. Okay, and in terms of p of x, now just start this. Just go y equals p of x. And then what do we write? We write 3y equals p of x. And then we write y equals 1/3 p of x. That's kind of why I wanted to do this one first, right? It's just sort of like, this is general. And then all I got to do is say, okay, where I see p of x, I can write root x minus 6. I write root x minus 6, and I can take a third. But either way, it's the same difference, right? But it's just asking you different forms, right? This is more of a general. Hey, there's some general functions being stretched vertically about the x-axis by a factor of 1/3. What is it? And then here's a specific function, and watch out, okay? Right, 1/3 and 1/3, third of this, third of that, third of that. The graph of y equals fx, where fx equals the absolute value of x plus 1 is sketched along with 2 other functions. So here's graph number, so here's the graph, absolute value of x plus 1. Here's graph number 1 and graph number 2. If you must. Just in theory, sign out in the office, right? So if g of x is equal to 3 times f of x, then the graph of g of x can be represented by graph number. Okay, so what's in words? What's going on? G of x is 3 f of x. What are we doing to f of x? 3 times fx is a what kind of stretch? Vertical by a factor of? No, it's over there. It's on the right-hand side. Vertical by a factor of 3. Okay, I need a vertical stretch by a factor of 3. What's that going to do to this point here? Like it was 1 unit above, now it's going to be 3 units above, so it must be graph number 2. Okay. What else? There must be some other hints as to, well, this was the point 2, 3. If I stretch it by a factor of 3, it's going to become the point 2, 9. Right? Because what are we going to do? We're going to multiply the y value, or just think about it. The image is going to be x is mapped to x comma 3y. So when y is 1, now y is 3. When y is 3, then y is 9. Okay, anyway, it's number 2. Write the equation for g of x in terms of x. So, okay, really all we got to do is write g of x is equal to 3 times this. How much do I want to show? So it's 3 times, okay, what's f of x? So let's bracket off the f of x, right? Because there's 2 terms in there. So we'll just say, okay, 3 times this. So then g of x becomes, extend that a bit. So what's g of x? 3 times the absolute value of x plus 3, right? Don't get caught. Okay, again, distributive law, right? Okay. I mean, you can even look here because you say it's got to be a 3. So like when x is 0, that's 0, and then that's plus 3. So that's the only way I'm getting up to 3. Graph number, I'm going to take a wild stab here. Graph 1, maybe. So we may give you more graphs than there are blanks to fill in, and actually we should go look at this. Like, okay, so in words, what's going on here? That's a horizontal stretch about the y-axis by a factor of 4. So then it should be wider, which it is. This point, the y-intercept should be invariant, right? Because if you're stretching about this line, stretching horizontally, you're going this way, so I'm moving further away. This is 1 unit away, now it should be 4 units away. This is 2 units away, now it should be 8 units away. And it is, so it is graph number 1. Write the equation of for h of x in terms of x. Okay, so what are we going to write? So what's it going to be? Absolute, that's an absolute value. The absolute value of yeah, so plus then you say, so if the original x value were 1, then I'm going to make it now 4, take the absolute value of 4, which is 4, and then add 1, which gives me a 5. So I should end up at an x value of 1, and then, wait a sec, so I should end up at 5. Is that what you're saying? Wait a sec, 1, put that in. 1. Yeah, it's not 4x, is it? Quarter x. Okay. Stretch is by a factor of 4, but it means x is replaced with 1/4 x. Okay, now I put I don't want to put an x value of 1 in here, because it's going to be weird. Now put an x value of 4 in there. 4 times a quarter is 1. The absolute value of 1 is 1, and then I get 2. So I put a 4 in, and I get 2. Yeah, I do. Okay, so you have a way to check, right? You can go back to the graph there and say, wait, that's wrong. If I put a 1 in, I'm getting a 5. No, that's not right. So you've got to put in a... Okay? So it's stretched by a factor of 4, but x is replaced with a quarter x. We just do that. The graph with y equals p of x, whose equation we could very easily figure out, it's x minus 2 quantity squared plus 4, is shown. State the domain and range. What are they doing for domain? Let's use interval notation. What's the domain? Come on, domain of a, this is a quadratic, there's arrows on the ends. Oh. So it's from negative infinity to infinity. It's all real numbers. The way we say all real numbers in interval notation. Open parenthesis. Why open? Why not a closed parenthesis? Shouldn't you include negative infinity? No such thing, right? So yeah, so negative infinity to infinity, it's closed. And the range is? What kind of bracket? Square bracket. And you can never put a square bracket next to an infinity, so don't. Well, okay, you can, don't. It will be wrong. It's just wrong. You can't, or you can do it, right? It's like I can't stop you. Complete the following table. 2y equals p of x. Description of transformation. So what kind of stretch? Vertical stretch. About the, by a factor of 1/2. What's the image point of xy? X 1/2 y. What's the domain and range? Will anything change the domain? So domain. What's the range? So instead of 4, it's 2, right? Vertically stretched by a factor of half. Just take half, right? Y is replaced with 1/2 y. Y was 4, now y is 2. And invariant points? Where are the invariant points? If you're stretching about the x-axis, they'll be on the x-axis. Any points that won't change? No, they'll all change, right? Like this goes to here, that goes to there, that goes to, they all become back. So there are none. None. Okay, you do the next line. I shall pause this, right? It's already 47 minutes in. Okay, how's that?
Did you use the wrong bracket?
Yes. Good catch. I threw that in there not on purpose. So it's a horizontal stretch about the y-axis by a factor of 2. The image point, 2x, y. Domain cannot change under anything we do. Stretch, reflection, translation, it's all real numbers. We're going to make it 2 times all of the real numbers because it's stretched by a factor of 2. Now it's negative 2 infinity to infinity. No, right? No such thing. The range stays the same as the original, right? Nothing happened there. And the invariant point was 0.8. Okay, next one, you've got to do how many stretches? 2 stretches? So, do the 2 stretches. Okay. Yeah, I didn't want to carry on with the rest of it because, you know, make it stick. But okay, it's how does the domain change now that it's only half of what it was? It can't change. Okay. There is nothing that can change the domain of a quadratic, right? Other than restricting that domain or something. And what happens to the range? Triple. So don't write 3 infinity though, right? And are there any invariant points? None? Okay. I mean, there is, with the horizontal stretch, there's an invariant point, but then it gets stretched vertically, so now it moves. Right? See, if you look at the original, the rest of it's just this, right? Yeah, you can do those on your own. So Under horizontal stretch, this is invariant, but under the vertical stretch, it goes to 24. This point here is the ultimate invariant point. Okay? Because what happens if you stretch this about the x-axis? Where does it go? Stays where it is. What happens if you stretch this about the y-axis? Where does it go? Stays where it is. What happens if you reflect this about the x-axis? What happens if you reflect this about the y-axis? What's the only thing that we have studied so far that will move this point? Translations. So that's why, if you remember back in 20-1, we started with a general quadratic, right? You take a general quadratic to a horizontal stretch, a vertical stretch, a reflection about the x-axis, reflection about the y-axis, that point's still there. So if you know you started with y equals x squared, and you want to know what's going on, and the vertex is here, you could say, I know my translations, because it went right 7 and up 4, right? Because that's the new vertex, and then whatever else I can figure out. But you know, I don't have to worry about it. This thing did not move until the whole graph shifted. Okay, that has nothing to do with nothing. Okay, so homework is as it is, right?